In this video, I want to take a look at some other identities that come from reflection, the even and odd ones we got from reflecting the angle across the x-axis. This time let's reflect the angle across the y-axis. So I've got an angle here in standard position. I'm thinking of it as, the angle starting here and going up to there. Starting on the x-axis, going up to that terminal side. There's a point on the terminal side, a comma b. That tells me that this side length is a and this side length is b. Now if I reflect over the y-axis, this is going to put a similar triangle or a congruent triangle over there, where this vertical side is still length b, and so the y-coordinate on that is still b. The x-coordinate, on the other hand, same distance away from the origin, but in the other direction now, in the x direction. So we've got negative a. So the coordinates here are negative a divided by b. Whatever the radius was here, it's going to be the same over there. A squared plus b squared, take the square root. So now I've got a lot of different things here. First of all, if this angle was theta, then this angle is theta. This ray, though, if I'm thinking of it as the terminal ray of an angle in standard position, then I'm talking about this angle right here. That angle right there is how much? Well, it's actually the supplement to angle theta, because if you take that angle and add theta onto it, you get to 180 degrees. So I'm going to be looking at the trig functions of 180 degrees minus theta. That's the reflected angle across the y-axis. Theta is this angle. That terminal side gets reflected over to here, and you're talking about this angle there, 180 minus theta. So I want to know, what's the sine of 180 minus theta? 180 degrees minus theta. Well, the sine would be the opposite over hypotenuse. That's b over r. How does that compare to theta? Well, for theta, b over r is the sine of theta. So the sine of 180 degrees minus theta is the same as the sine of theta. How about the cosine of 180 degrees minus theta? Well, the cosine of 180 degrees minus theta would be, here's the adjacent side over r. That's negative a over r. Well, for theta, a over r is the cosine of theta, so I've got that minus sign out in front. Okay. So the sine of the supplementary angle was the same as the sine of the angle. The cosine of the supplementary angle is actually minus the cosine of the angle, because your x-coordinate changed sign. Likewise, the tangent of the supplementary angle is, let's see, what would it be over here? B over negative a. Well, b over a is the tangent of the angle without the minus sign, so this must be minus the tangent of the angle. Okay, so there's reflection across the y-axis. I only do 3 of the trig functions, of course, because the other 3 are just reciprocals, and that the cotangent will behave very much like the tangent, because it's just the reciprocal of that. The minus sign shows up, so you're going to have minus the cotangent. Likewise here in the cosine, since you're using the a and the negative a, there's a minus sign here, and the secant of the supplement will be minus the secant of the angle you start with. Sine and cosecant will behave the same, because they use the hypotenuse and the opposite side, which didn't change. Neither r nor b changed when you reflected, and so the cosecant of the supplementary angle will equal the cosecant of the angle. Okay, just flip the r and b upside down. Okay. There's another reflection that is of some interest to us. In fact, it's going to turn out we've already looked at it, and that is reflection over the line y equals x. So if I have an angle here, so here's my angle in standard position. Again, I'm going to say that's a and that's b, so the coordinates of that point are a comma b, call the hypotenuse r. And now I'm going to reflect over the line, I didn't really want orange, I want over the line y equals x. So this angle that's going up from the positive x-axis, now I think of it as coming down from the positive y-axis. So let me go back to blue, and I've got this angle. Sorry, let's not do that. Let's do this. There we go. So I've got this angle here, and I got to take this whole picture and move it down. There we go. So I can extend this out a little bit further and drop that over there. Okay. That is, by reflecting across the line y equals x, I have now taken this triangle and reflected it up to there. So the A that was there is now the A that's here. The B that was there is now the B that's there. The coordinates of this point, now careful, the x coordinate is B, the y coordinate is A, right? My perpendicular is dropped in the wrong direction, so I got to be careful. The x coordinate here is the same as the y coordinate there, and the y coordinate here is the same as the x coordinate there. Okay. Typically, I'm going to want to drop a perpendicular down here and say, oh, this is B and this is A. So the thing is, I started with this angle, the terminal ray was there. When I reflect that terminal ray up to here, I'm now looking at this angle in standard position. This angle right here is theta, because that's what got reflected up. So this angle right here is actually the complementary angle. That is, that angle is 90 degrees, looks ugly, 90 degrees minus theta. And I'm going to ask questions about that. But we've already seen the cofunction identities, but here it is again. If I ask what's the sine of 90 degrees, 90 degrees minus theta, what's the sine of this angle? Well, that would be the opposite over the hypotenuse. Did I give the hypotenuse a name? Yes, it was r, so it's going to be r again. It's a over r. That's the same as, I didn't write what I said. I said a over r. Well, a over r down here is the cosine of the angle. The sine of the complementary angle is the complementary sine of the angle. Likewise, the cosine of 90 degrees minus theta is this angle here. The cosine is b over r. That's the sine of the complementary angle. The sine of the angle down here. B over r is the sine of theta. B over r is the cosine of 90 minus theta. And lastly, let's do tangent here. Tangent of 90 degrees minus theta should be a over b. But for theta, that's a over b. That's the cotangent. These we saw as our cofunction identities. It's reflection across the line y equals x.